Welcome to today's presentation on recap and practical examples applying design principles and patterns in code. In this session, we will be revisiting low-level design and object-oriented design principles, and we will dive into practical coding examples. Let's get started. Here's the agenda for today's session. First, we will recap key concepts of low-level design and object-oriented design. Then we will move into practical coding examples to solidify our understanding. Lastly, we will explore real-world use cases and have a discussion on how to apply these principles effectively. Let's start by revisiting low-level design. LLD is about translating the system's high-level design into detailed, implementable solutions. It focuses on class designs, methods, data structures, and their interactions. The key difference between low-level design and high-level design is that HLD covers system architecture and module interactions. LLD deals with the finer details of how each component is built and interacts with others. Now let's recap object-oriented design. The core concepts of OOD include classes and objects, encapsulation, abstraction, inheritance, and polymorphism. These concepts help us build flexible and reusable systems. Classes define the blueprint, while objects are instances of those classes. Encapsulation ensures that the data is hidden within objects, while inheritance and polymorphism provide mechanisms for reusability and dynamic behavior. Next, we will quickly recap the first two solid principles. The Single Responsibility Principle (SRP) states that each class should have only one reason to change, which simplifies maintenance. The open-close principle tells us that classes should be open for extension but closed for modification, allowing us to add new features without altering existing code. Let's move on to the next two solid principles. The Liskov substitution principle says that objects of a superclass should be replaceable with objects of a subclass without affecting functionality. The interface aggregation principle (ISP) suggests that clients should not be forced to implement interfaces they do not use, promoting cleaner and more manageable code. Finally, we have the dependency inversion principle (DIP). This principle encourages decoupling high-level modules from low-level modules. Both should depend on abstractions, which allows for more flexible, testable, and maintainable code. Design patterns are reusable solutions to common software design problems. There are three main types of design patterns: creational, structural, and behavioral. Creational patterns deal with object creation. Structural patterns focus on organizing components, and behavioral patterns handle object interactions. Let's look at a practical example of the single responsibility principle. Imagine we have a class that handles both user authentication and logging. Following SRP, we separate the concerns into two classes: authentication service for authentication and logging service for logging. This makes the system easier to maintain and extend. Next, we will apply the open-closed principle using the strategy pattern. Suppose we need to support multiple payment methods in an e-commerce application. Instead of modifying existing classes, we extend the functionality by introducing new strategy classes for each payment method. This way, our system can easily accommodate new payment methods without altering existing code. Now let's see the dependency inversion principle in action. We have a notification system, and instead of tightly coupling high-level modules like notification service to low-level modules like email service, we use dependency injection. This way, we can easily swap out the email service with another service, promoting flexibility and decoupling. Let's consider a real-world example of a library management system. By applying solid principles, we can design a scalable and maintainable system. For instance, by using the open-close principle, we can add new features like book reservations or fines calculation without changing the core logic of the system. Here's another example, an e-commerce checkout system. Applying solid principles in this case ensures that the system can easily handle multiple payment options, discounts, and user promotions without cluttering the code. It also helps in maintaining clean separation between modules like cart management, payment processing, and order fulfillment. To summarize, we have gone through key design principles and patterns, including solid principles and their application in real world examples. Now, I would like to open the floor for any questions you might have. Feel free to ask for clarifications on anything we have covered. Thank you for attending today's session. I hope you found the content useful. If you have any further questions or would like to continue the discussion, feel free to reach out to me. I look forward to seeing you in our next session. Have a great day.